Let's talk about end-to-end tests in React Native apps. Maybe some infrastructure around it. Maybe something else. Maybe we'll not talk about React Native tests at all. We'll we'll talk about a bunch. Just maybe quick intro about me. I'm Michał Pierzchała, principal engineer at ColdStack. We're doing software development for many big companies, and we're specializing in React Native. What I personally like to do, I like to build dev tools. Tools for developers, infrastructure, and as a part of that, I get involved in some open source projects such as Jest or React Native Testing Library or React Native Community CLI, and something new that we're building that we're gonna give you a sneak peek. So you can find me on X, Twitter, or Blue Sky, or GitHub under this Daimaki theme handle. And yeah, let's start with that it's not a talk about end-to-end testing, because let's face it, how many of you write end-to-end tests on a daily basis or like once a month? 1, 2, 3, 4, 5, like 6 people. What about the rest of you? You're probably developers, right? So you suck at writing end-to-end tests. I can feel you. This is just, truth, statistics, etc. So developers are not great at writing tests. Even unit tests or integration, although they're a bit better around that. If it comes to UI or end-to-end tests, please just leave it to QA engineers and focus on something more important that you can help, which is infrastructure. So there are multiple ways you can end-to-end test in your React Native application, whether it's a mobile iOS, Android app, or a macOS app, desktop, web even, and some others. You can use Detox, likely. This is not my preferred choice because it's a gray box testing. It's very coupled to what React Native is doing, so you will have hard times upgrading from older to newer versions of React Native and Detox, etc. Probably if you don't use it, I wouldn't start using it. Another one is Maestro. There's like a new entrant to this end-to-end business. It's pretty great. It has a really nice developer experience, and you can feel they focus on how to do the little work to make your end-to-end tests a little bit less brittle, less flaky, and work. They work on iOS, on Android, on simulators. Sometimes they work on devices, but they don't want on some other environments. And there's Appium. So if you write your end-to-end tests for a startup or enterprise that wants to, that has their product on as many platforms as possible, this is likely what you're going after. I know it's like old, not sexy, it's not new, but it works in many cases. And what's most important, it's gonna work in some environments that we will touch later. So there are multiple reasons to write end-to-end tests. For us developers, it's mostly smoke testing. So if you're able to spin out Maestro test on some simulators or emulators in one day, that's probably fine. I wouldn't invest more time in that. Just test is my app opening? Is it getting through checkout or whatever? Done. The rest, I would leave it to QA engineers. Another thing is testing correctness. So this is the part where developers are not really great at. They're not great at figuring out what's how to break an application. They're usually I'm speaking from my experience. There were multiple times I was building software and I knew about some little bugs, but I just happened to not tell anyone about them and hope that maybe someone will discover that, or will just get fixed or get discovered by a QA engineer or some user in the wild. That will be the worst. But yeah, this is just my nature as a developer. I'm focusing on solutions, not finding problems. And QA engineers are great at finding problems, so they will handle all this correctness of our application. And also we can test performance, because if you wanna test performance on your app, you can do it as with tests on multiple levels, either on the JavaScript or React side. But if you really wanna test like your time to interactive, your FPS on an actual app that real humans or LLMs are using, you can go. You'd likely like to write some performance tests on your fully blown native application. So to me, the real reason to write tests is to just move faster. And you can move faster by spending less time finding with regressions. And tests are helping us preventing regressions. So I wouldn't invest too much time in doing that. You're likely gonna have better time investing more in real-time user metrics and observing your actual users, what they're doing, when they're failing, where they're having some bad time. And if you happen to find a regression, you can write a test for it. So yeah, it wouldn't be a talk about end-to-end testing without the slides. So you've probably seen that on Martin Fowler's blog or somewhere else. I'm not sure if this is clicker work. No, that doesn't work. Yeah, so we're talking about not unit, not service. This is like, backend people talking about end-to-end testing. We're focusing on the UI layer. You can see a lot of dollars there because it's like usually expensive. You can see a little turtle there because it's, it requires a lot of resources. It's going to be slow. So you want to spend as little time as possible there and as much time on the unit or integration phase. So listen to smart people like Martin Fowler. So where these end-to-end tests can actually run. So you can run them, locally, but then no one else will see the results of those tests. You can see, you can test and run them on a continuous integration server with a simulator. You can hook up a CI with some real machines. So imagine, I'm pretty sure there are people there who have like a Mac Mini somewhere in your office or a laptop of other kind that serves as your CI. Do we have people like this? No? Okay, we have such setups. And you can hook a real device to that. So you can treat that as your simulator, but you have a real device. So this is really cool. And we have a device farm. So we can actually upload our app to a specialized service that can run on real devices or emulated devices, whatever we like. There's a lot of to pick from. And we can run our tester. And this is where master will fail you, because there is likely no integration with existing device farms, such as Browser Stack or AWS Farm, and many more. So let's take a quick look of what are the prerequisites and some steps for running our tests. So this is the infra part. This is where I like to spend my time, not actually writing tests. So that's why I was a contributor to Jest and not really written too many tests in that, but I written some. So with the CI, with a simulator, we have some things that we will need to set up once. This is we'll need to write some code for our continuous integration server, and we'll need to set up our simulators. And this is like super painful. If anyone tried that, you probably know what I'm talking about. If not, just don't do it to yourself. Yeah, so for once we have the setup, we can build our app for the simulator target. We can then boot the simulator. we can install the app, and then finally we can run our tests. So there is a similar story for CI with physical device. The difference is that we'll have extra hardware setup and the device, like real device setup. And there's like one less step to handle because we will need to build our app for a target device, but we will also need to sign it. So if you haven't done it before, that's going to be a bit of more work. You won't need to boot up the simulator because the devices are already connected. So you just install the app and run end-to-end tests on it. And there is a device farm. So once again, we once set up the CI, then we set up the device farm. Of course, we'll need to pay for it or spin out our own. That will be like extension of the second scenario. And again, we build the app for the devices. We upload the app to our farm, it's usually through some API requests, and run our end-to-end tests, usually with Appium. They have a really good integration for that. So there is one common thing with all those steps, apart from running tests, is that teams will build the app for some target every time they will run tests. And this is what happens there. So this is a actual screenshot from Expensify app. It's an open source app you can open there. And they have a suite of end-to-end tests related to performance. So you can see they run like 1 hour 38 minutes, 1 hour 45 minutes. Basically, it runs 1:30 to 2 hours. And you can also see they're triggered manually because who the hell would automatically run a CI job that runs 1 or 2 hours, right? And this is the dangerous things that happen when things on CI get slow. If they're getting slow, they're getting also expensive. There is a slower feedback loop, and developers just disable those. So in many cases, you will find that companies are just not running those end-to-end tests because it's too expensive, because it takes too much time. They will run it like nightly or maybe twice a day. So what if we skip the build and save us some time on that? So let's take a look at one of those actions. We can see finding some stuff. It takes like 1 minute. We can see building for Android. This is actually building 2 Android apps. Oh yeah, because this is gonna build the baseline and our branch. So we're twice building our Android app. Then we schedule run on AWS device farm. It takes 1 hour. I have no idea what they're doing there, and doing some cleanup. So there is this opportunity to shave off like 25 minutes from the overall CI side and like 50 minutes of overall compute. So if we've done that, and assuming that we are also doing it for iOS, we will have like around 20 minutes less spent on the macOS runner, which is 10 times more expensive on GitHub Actions, and also anywhere else. We have 20 minutes less on Linux compute. And for this little pipeline, it's like $2.2 of savings, and the money cost is just a part of the equation, because what happens in those 20 to 50 minutes to an hour is that the developers are waiting. They're having developers are really well paid in most of the parts of the world I've been to. And if they're waiting for builds and then just say, hey, I'm just compiling, yeah, it's pretty expensive. So for one company that we worked with, they have like 80 or 90 people in their dev team combined with QA. That time they spend waiting for builds and like their regular builds that could be cached, basically, wouldn't need to happen, and the builds that need to happen for the end-to-end testing, it accumulated to 1,000 hours a month This is like 6 people full time just doing nothing but waiting. This is pretty much waste. So why those companies are not just skipping the build? Should be easy. Maybe because reliable caching of native builds is it's really hard. It's most of the companies we've seen when they try to do it, they're not very good at it. They try to optimize the build process, something that Expo is great at, something that React Native core team is great. But those poor developers, they're not very best at optimizing those Xcode and Android builds. And we also have the remote storage that would allow us to reuse those builds across different jobs, different workflows, and not only the build that we have as part of a single workflow. So yeah, most companies that we work with are doing it wrong. And they're like, Fortune 500 companies making billions of dollars can't do this simple thing like caching your native build. And I don't blame them. This is actually a hard problem. And as you probably know, caching is one of the 2 hardest problems, apart from naming. Naming is even harder. So what I would like to introduce you briefly to is something that we're building to make it all go away for any enterprise company out there by doing it once and doing it well and doing it in open source. And this is our React Native, our new React Native framework that we're designing for the enterprise. We want you to build once and be able for you to reuse that build from your infrastructure between your CI jobs and also between all of you as developers, teams. Something that Wojtek mentioned that EAS build dev is allowing you to do. But imagine that on your own infrastructure. So what is a React Native Enterprise Framework? It's a CLI, which is a replacement for the community CLI. It's like 5 or 10 minutes migration. It's a remote cache. So this is this whole concept that is tied to CLI and allow you to seamlessly download those builds and manage the caching. So we were hearing about the SKU protection, for example, that Vercel was doing for us in their server apps. This is something similar. So remote caching is allowing us to, together with some fingerprinting method, which we're using, will allow you to identify a specific build that is native and where no native changes have been made, and we only made our changes in JavaScript because from what we found, 70 to 90% of the changes that we make in React Native apps is happening on JavaScript side. And we have the concept of headless configuration, so we can plug out our implementations with yours for not everything, but for a lot of stuff that you would like to. So if you'd like to adopt our framework, it's an incremental migration. You can first integrate and adopt the CLI, and then on top of that, you'll be able to get access to this remote caching where most of the value lives. So while we're building that, because there is a common set of challenges that enterprises are solving on their own, and they're not making really good job at it, mostly. And to make it easy to adopt React Native for any native application out there, because today it's not very easy. So these common challenges are high build times with no reuse between CI jobs and between the dev team. It takes months to integrate a third party that's not already available for the dev team in many enterprises. So if there is this great cloud company that you would like to buy services from, if you're in a big enterprise, say hello to talking to legal department for 6 months or so. So those companies those teams then stop thinking about adopting, good or even better tools that they have today, and they just build on top of what they have today. There is a mixed stack for those older applications that are either adopted React Native somewhere in the past or wants to adopt React Native, and there's not an easy way to just add React Native with all the complexities with CocoaPods, node modules, etc. to those existing apps. And also there are some companies that we work with that ship to 10 platforms or more, and we want to cover that. And we also want to cover the brownfield solutions to make it just easy to add React Native to any app without messing with node modules, CocoaPods, etc. So you can just import React Native in your iOS app, and it should just work. So the new CLI is a 10-minute migration. It has better developer experience and performance compared to the community CLI, and it's compatible with the remote cache. It looks more or less like this on the API front. You'll see there are some pretty much the same commands that we have in the community CLI. They're slightly changed. There is build iOS, there's run iOS, and there is the sign iOS, which is one of my favorite. It allows you to strip your application, replace any part of it, for example, JavaScript bundle, and sign it once again. This is great for those end-to-end testing on CI. I'll get to that later. We have the same set for Android. Also, we added some helper for creating key store. This is mostly for us for development. And we have start and bundle, which may come from a bundler plugin like Metro or Repack, because we don't want to make assumptions on which bundlers you're working with. So you can bring either your own or using the two existing ones in the ecosystem. So the CLI looks like this. In this scenario, we will tell you we're running an iOS command. We found some local cached build for iOS simulator in debug configuration. Okay, we found some devices simulators. We're letting you know what we're doing. As a CLI, we're launching the simulator, installing the app, launching it, and calling it a day. And something that you may want to, you may wonder, what's this? Is this weird cache? And this is the fingerprinting mechanism, something that is possible thanks to Expo fingerprint package made by Kudo from Expo team. And this is great and something that allowed us to pull off this remote caching that seamlessly work with the CLI on any kind of infrastructure that you have. So the next part is the remote cache, because the best build is no build. Most of the builds out there on our CI just don't need to happen. So it's about smart reuse of those builds. It comes with out of the box support for GitHub Actions, and there are adapters for storing your native builds on S3 or some other CI providers in our pipeline and roadmap. So on a high level, it's working like this. You open the CLI. We're checking the checksums during running Android or running iOS. We're checking whether there is a build cache. If it is, then we fetch it from the remote cache. If it's not, we build it on, for example, a CI action, and then store it in that cache so it's later available for our CLI and for other builds. And with that, you're able to. What I'm showing here is that there are like 2 jobs for building your app in release and debug mode, and they take 35 and 33 seconds. There's no way we can build an app that fast, at least not yet. But there is if you're not building it. This is only the time it takes to install the NPM dependencies and spin up some virtual machines, and figuring out that, hey, we already have that built for those native files that you already have here. So we'll just skip it and let you know where to find that build, and that's it. And that's like most of the work that's happening in our React Native repos. In the spirit of headless configuration and the modular design, we made sure that you're able to provide your own remote caching solution, so we can implement this interface. This may change in a moment, but we haven't released publicly released that software yet. So just to present the idea, you can provide your own storage, because every company is different, and they will have access to either S3 or R2 or some Jenkins artifact storages, and we may not be able to implement everything. So we'll give the power to the developers so they can write it themselves based on reference implementation. The brownfield, this is interesting to me, but I want to source whether brownfield applications are interesting to you. So any of you already tried implementing React Native in a native iOS or Android application? Okay, we have 1, 2 hands, 3, 4-ish. No, yeah. So there's not much of you. So I'll try to skip through the code that may be unreadable to you, but to give you the base idea. What we're doing different from React Native today is that with our framework, you're able to install the plugin for brownfield. You'll need to configure some stuff some targets and code in your Xcode and Gradle to produce a framework, because we package all the React Native stuff, all your React Native app in a framework, so it's available to import in a native application. We're doing that through the package command, which is available with our plugin, and then we allow you to consume that framework in your native application. So this is adding the plugin. It's as easy as defining a plugin for brownfield iOS. So I'm sticking to the iOS example here. We define a target in our pod file. We're running this command for our new scheme and the release mode, but we can use the debug mode if you like. That may work. And we can adjust our app delegate or scene delegate. In this case, I just picked app delegate and extend it with a window, because that's like requirement currently for opening a React Native application. And then you can see we import like framework, target, whatever from that we just generated with our package command, and we can instantiate it with React Native Manager and loading particular view. This interface will also change because we're going to integrate that more and more with our React Native brownfield library. So it will get better. I mean, I won't say it's going to be less code, but it's going to be more capable. And last thing on a feature side that we're focusing for this framework is out of 3 platforms. So we want to treat all the platforms in the same way, whether it's iOS or Android or macOS. It's for our system, it's a plugin. So we provide those plugins, and those plugins provide commands and templates for Windows, for iOS, macOS, and whatnot. And iOS and Android, we are shipping by default because that's the default in the React Native community as well, and you can ship yourself. So this is how it looks like in a base configuration. this is what your configuration will look like, more or less. You'll have those dependencies set explicitly, so you also need to install this platform iOS and platform Android dependencies. There's no way around it because, again, we're treating all the platforms in a same way. And you can install your own custom platform just like this. So and this is a part about our configuration system and our design direction, where we favor modularity, because in enterprise software, there's no one solution to do something. There is like hundreds of solutions, and we need to be flexible and allow developers and those teams that are working in infrastructure departments for those front-end developers to be able to just rewrite parts of our framework without us knowing about it. So that's why we're defining a bundler that you can provide your plugin for. You can add your custom plugins, you can add your platforms, and you can define your remote cache provider. So we have a documentation for that, even though this is not a public project yet. But you're able to play with it today if you follow the documentation. But it's not officially released. So if you would like to play with it, there is a documentation. You can follow it. You can also sign up for the wait list. I'm gonna show you the code, and also you can reach out to me after the talk. You can also meet with us at a next meetup that we'll host in San Francisco, but it's also gonna be hosted online. So make sure to scan this code. I hope it's nothing scammy. Yeah, it's not. And you'll be able to join us for our special event that we host together with Expensify. And some small conclusions that I wanted to leave you with is that you should only test what's crucial and what regressed in the past, ideally. Majority of native builds are just unnecessary, also for iOS, for CI and for developers, and can be avoided. Working with CI is a pain, so try to outsource it to different packages or to EAS if possible, as much as possible. And if you cannot outsource it to some third-party cloud, stay tuned for our enterprise framework. Thank you very much.